Hello everyone. So you can see that we are discussing very important research projects, and their implementation, discussion on how we have conducted that experiments. So this is very important for you if you are in this field, if you are doing some research work, and this is for both PG and PhD work or for PhD kind of project. So if you have any doubt, you can ask me for comments. Now you enjoy the presentation and try to learn that what our groups have done under my supervision. Well, let's start.
Robo.
And you can put
Oh, okay.
screen in the full screen mode also.
Sir,
Yeah,
দেখা পাইছে?
দেখা পাইছে.
Robo.
Please,
Sorry, Robo.
একো নাই.
Share.
Yes, it
এক
is.
second, Robo.
You can see the screen.
Hi, hi. Sir, but আমি দেখা নাই, Robo. Sir, so today we are going to present our project presentation about ovary cancer detection system. I'm Krishnangi and she is my co-presenter Daisy Goswami. So these are the contents of our project presentation. Take it ready. So our project aims to build a system which build a ML model to help to detect ovarian cancer early and have a model with which improve accuracy and efficient model in detecting ovarian cancer. So ovarian cancer is a serious disease that is often found late because of its not clear symptoms. That's why it requires expert knowledge, and therefore there is a strong need to need for an automate an efficient and accurate system for that can assist in early detection for ovary cancer. So for solution overview, we are using a CNN, which is a deep learning model, which is a deep learning algorithm that is especially powerful for processing images, videos, or any data that has great light topologies and like pixels in photo. So this is the CNN architecture, like how the CNN architecture are works. So first is input. So here we are using a basic photo image. Sir, देखिए ऐसे ना.
Yeah, yes.
Oh, okay. So the first layer is input layer. The process starts with an input image, which are using here, which is converted into a pixel matrix. Here we are using a kernel, which is like a filter, is applied to extract features of the image. After that feature extraction, then pooling layers. Here we convolution layer, which detect the edges and textures and linear unit, which helps to remove negative values of the image and introducing non-linearity. Non-linearity means it helps the model learn more complex patterns. There are three pooling layers. After that, there are there is a flattening layer, which which helps which helps to convert these feature maps into a 1D layer, 1D vector for classification. After that, there is a fully connected layer, which is uh, act as a traditional convolutional neural network, which learning it is a decision for classification. After that, there is a softmax activation function, which assigns the probability to each class. The highest probability determines the final classification of the output. So here we can see zebra has 0.7 probability, the model classifies that the input image is a zebra. So this is clear. We can use this model or technique in our project to classify medical images. Next one is mobile net version 2, which are also deep learning algorithm. So this is widely used for tasks like image classification, object detection, semantic segmentation on mobile and edge devices. So this slide basically theory of mobile net version 2. So I'm directly moving to forward to the architecture, how it works. So mobile net version 2, okay. The first block is input layer. So the input layer takes an image and prepares it for processing. The image is first passed through a standard convolution layer to detect basic patterns like edges, colors. So after there is a several bottleneck blocks. It is for efficient for feature extraction. So these bottleneck layers are the core of the mobile net version 2 technique. So so after that, there are so these are the main building blocks of mobile net version 2. So the next block, bottleneck layer in layer block, we can see there is a one input layer. After that, 1-into-1 expansion layer, which helps increase the number of channels to learn better features. Then there are 3-into-3 depth-based convolution, which reduce the computation by applying separate filter for each channel. Then 1-into-1 projection layer reduces the number of channel back to compact size, making the model efficient. This bottleneck layer is in the bottleneck blocks. So each bottleneck block also has ReLU activation and skip function, which helps to retain important features of the previous layers. After that, we can again come back to the first block, then convolution 2D 1-into-1, that after passing through multiple bottleneck layer, the feature maps are processed using global average pooling and final 1-into-1 convolution layer before producing the output. So this method significantly reduces the computational cost, maintaining the accuracy. This is how the mobile net version 2 architecture works. After that, they will continue the other parts.
Thank you, Krishnagi. Next is the methodology. First is the dataset collection. We collected our dataset from the TCGOV, which is a medically like institution. We can say the Cancer Genome Atlas Ovarian Cancer. It consists a huge variety of cancerous images. So from here we have collected our data set. These are some, we have some collected some histopathological images, which are like some microscopic pictures of tissue samples taken from the body, likely from ovarian tumors. Then we have pre-processed those images, resizing images to 224 into, like we have resized it to 224 into 224, which is the height and width of the pixels. Then we have normalized it, like scaling the pixel values between 0 and 1. So this means the pixel size, pixel values vary from 0 to 225, which is a default value. So we have sum up and we have considered the values from 0 to 1. Okay, so this is the normalization. And then we have done the data augmentation, means we have trained our model by rotating, flipping, and also zooming the images, which is the data augmentation part. And like through these steps, we have pre-processed our images, that are included in the data set. Then here comes the training and evaluation. We have trained our model using the parameters like batch size, epoch, image size, augmentation, and rescaling. Here batch size, we have images per batch. Okay, so we have considered 207 batches of the data set, and these 207, each batch would contain 32 images. So the image the model will like loop over these batches and be training on that. And then the epoch means we have used 10 epoches. Here our model will be looping over this 10 times over the training data set. The image size, as we have said, like 224 into 24 pixels. Augmentation, we have defined rotation, flipping, zooming. Rescaling, the scaling or normalization of the images. Performance metrics, here we have used the accuracy, we have shown the accuracy of the model. Deployment, then at last we have integrated both the deep learning models into a Streamlit app, which is a simple way. A Streamlit app is basically a simple way to turn our Python code into a web app without having a knowledge of like web development. Here the this is a like, we can say, a library, a Python library, which turns our code into a web app where we can upload our images. It will get detected and give us the confidence scores. So it is. So we have got the for CNN, we have got the validation accuracy of 0.9517 and validation loss of, these are like the we have, first of all, we have trained our model through CNN. We have used CNN for that. After that, we have trained our dataset to MobileNet version 2, and we have then combined this to CNN and MobileNet together for the ensemble weighted average model. This is also a deep learning the weights of these two models, deep learning models, and get and give the accuracy and loss. So as we can see here, the validation accuracy is more, it is the highest at the ensemble weighted average model. So we have deployed our web app using this. Here are the results and observations. Here we can see that this is the observation for results for the CNN model. Here the tumor, and we have got the like tumor detected and confidence scores of the model here. And for the mobile net, it is also, it has shown confidence scores are more for the ensemble model. So we have considered this when deployment comes. Then last, here is the deployment. We have deployed the as a Streamlit web app, as I have mentioned earlier. Then here in the web app, we have integrated machine learning models. We have integrated the CNN and MobileNet, which we have trained respectively, and we have combined that to a ensemble learning model. It is the app is very accessible and easy to use. We will show you. Then is the impact. Yeah, though this is it like predicts it gives a very huge impact on the patient. Like they can upload their histopathological images, like microscopic images or whatever. For now, we have tested and trained the model on specifically the histopathological images, which are the microscopic images of the tissues. So the users can easily upload the images and they can get the results. Not only users, the doctors also can use this web app. Okay, so here are some screenshots for our web app. Okay, so let me show you the demonstration. Sir, শুনি পাই আছে?
Yeah.
Yeah, okay. Wait, let me show demonstration. So basically, this is our Streamlit app. Um,
But we cannot see the app.
issue
I think
এইটো কাৰণে অলপ দেৰি লাগিছে।
তাত নেটটো কম আছে। এইখন স্ক্ৰীনখন তুমি গুগলটো গুগল টেবটো মিনিমাইজ কৰি পেলাই তালৈ যাব পৰা এপটোলৈ।
Sir,
হয়।
so it is basically an interface, a simple interface where we can like drag and drop the files here. It will take a limit of 200 MB per file. We can use JPGs, JPG. So here is our ovarian. This one is training and validation dataset. So we will be picking up a image from the
I
validation
cannot
set.
see the app.
Suppose we are. Sir, no, it is a web app actually.
কিন্তু ইয়াত দেখা নাই।
Oh, robo. Robo. Oh, সেইটো সুইচে কৰা নাই। এক সেকেন্ড ৰব।
Oh, yes. Now it is so visible.
Okay, so this is an interface as you can see. So here we will be browsing files. We have this
To search.
ovarian folder where we have the train and validation dataset. So we will be been uploaded of 17.9 KB. So wait, it will be, yeah. So here is the prediction. It is no tumor detected and it has a confidence score of 100. So again, if we go for a tumor image, randomly picking up an image. Yeah, the image has been uploaded and yeah. Sir, robo. Network to bear. দেখি আছে নে?
দেখি আছো।
Hello?
দেখি আছো।
ৰব আহিব। Sir, yeah, মানে এইটো এনেকা we have uploaded a tumor image as you can see and the prediction goes tumor percent.
Confidence 99%. Yes.
So basically this is our Streamlit
Yes.
app. Robo. আৰু আছে ৰব। Sir, are we audible?
Yes.
দেখিছে নে?
শুনাও পাই আছো, দেখাও পাই আছো।
Hello?
We can hear you.
Hello? দেখিছে?
Yes. We can hear you and we can.
Yeah. Okay, so these are the screenshots I have provided in the slide as I have shown the demonstration. As part of demonstration, here is the a valid tumor image and their confidence score, and here is the non-tumor image, also their confidence score. And this is the like ensemble model, the ensemble model that we are using. We have, like I have told you, we have divided the data set into 207 images batches, and each batch will contain 32 images. So the ensemble model is trained on these batches and it shows an accuracy of 97, which is the highest. Also, I have discussed this earlier, and 0858. Yeah, so this is the literary review. So as we have reviewed papers, or we have discussed,
Yeah,
like
literacy review.
we came over very other discussions as well. We followed research papers also. Here the CNNs are widely used in cancer detection, showing high accuracy in medical image classification. So traditional methods like earlier CA125 test and ultrasounds have limitations, as we all know. Making now the AI based solutions are making it valuable to detect the diseases as well. Studies confirm that MobileNet V2 performs efficient with small data sets. So the small data sets are effectively detected by the MobileNet version 2, making it ideal for medical applications. So it is well suited for this project actually. Here is the conclusion. Overall, the development and adoption of effective ovarian cancer detection are a vital step towards reducing the burden of this disease and offering hope for better long-term health for at-risk individuals.
Okay. Yeah,
So
very good project. And one
these
thing,
are some references,
yes.
and thank you.
Okay. So that is literary review or literacy review. You don't need to provide. You can just write the summary of the result or experimental analysis. Okay. And everything is perfect. They may ask you that
Sir,
how
কি কৈছে শুনা পোৱা নাই।
is my voice visible? Sorry, audible? Others can hear my voice, right?
Yes,
No,
yes.
no, yeah.
So everything is okay. And the term literary review, that should be literacy review. And you don't need to provide here. You can directly write like that, from the experimental result analysis, we have found this. That is more than sufficient. Okay. And be confident your project is really good. And you also have to say that you have submitted research paper that is under review.
What about the demonstration?
Demonstration is perfect.
Okay.
Okay.
So demonstration to ঠিকে আছে ন?
ঠিকে আছে,
Yeah.
ঠিকে আছে. This is perfect. But
Yes, sir.
tomorrow keep everything ready, right? As
Okay, sir.
kind of web-based, na? So
Okay, sir.
internet should be good. Okay, all the best.
Yes, sir. Thank you, sir.
Thank you. Good night. Good night. Okay.
Good night, sir.
Nipumani, you